binomial theorem. This is all the way back in 1.11, but we're going back because this is really something that doesn't necessarily need to be done. You can always do it the long way, but binomial theorem and Pascal's triangle really help us, especially when the values get bigger. So we use binomial theorem when we have binomials raised to powers. So if I gave you x plus 3 squared, you'd hopefully remember that you'd end up having, rewrite it as x plus 3 times x plus 3, and you do your double distribution and end up getting x squared plus 3x plus 3x plus 9, so x squared plus 6x plus 9, right? And you've done that since algebra 1, right? But here we have x plus 3 to the third. Now it's getting a little bit more complicated. So this we already know is that, based on the work I just did. So I'm not going to redo the work because it's already there. But normally you would have had to do this initially. And then I have to multiply out this way, right? And you could do that. There's nothing wrong with that. But, let's talk about if it was to the 7th power. It's very tedious, like to do the multiplication out. It's 100% doable. You can do it, but we can also use what's called binomial theorem. And so binomial theorem is this guy right here, that it's whenever you raise it to the nth power, you can do n choose starting with 0 and then moving it up, right? And choosing, remember, is like this specific formula that's down here. It's a combination, but I'll just kind of show you another shortcut for that. We don't need a calculator. And then it's the first term gets raised to the nth power, and that first term, every next term goes down by 1 until it would be the 0 power, so it's no longer there. And then the second term starts at 0 power, so not there, and then goes up by 1 each one until you get it up to the highest power. Okay, yeah, that's basically what it kind of points here. But the first part, which is what this video will focus on, is the n choose 0, 1, 2, and so on and so forth. So we can actually use what's called Pascal's triangle. And it's this triangle right here. And this triangle does technically go on forever. But the way it works is you count, the first row is row 0, and then count up from there. And so if you wanted, let's say, if we were doing, a plus b to the 7th, well, that would mean I'd want the 7th row of Pascal's triangle. So I'd actually want this row right here, because again, if you count from 0, 1, 2, 3, 4, 5, 6, 7, there's your 7th row, right? And you may be like, well, where do all these numbers come from? And like, how would this help me? Well, we can recreate Pascal's triangle as long as you know 2 things about it. One, you always start with your ones diagonally. So you start with ones going this way, start with ones going this way. And then once you know that, then every row after row 0 is created by adding the 2 terms above it. So again, starts with the 1, but then the next term is 1 plus 1, because those 2 are right above it, gives you 2. 1 plus 2 is 3, 2 plus 1, also 3. 1 plus 4, 3 plus 3, 4 plus 1. 1 plus 5, 4 plus 6, 6 plus 4, 4 plus 1. And you'll notice some symmetries that happen here that feel like creating this much easier. Once you make it halfway, you have this symmetry that you then can be like, oh, okay, after 20, it's going to repeat 15, 6, 1. Right? And I can keep going, right? If I wanted something to the 10th power, I would just go down to row 10, where it goes 1 and then 10. So yeah, if you're looking for a specific term, so let's say this was 7, then I was looking for the third term in this. Well, the first term is n choose 0, a to the 7th, plus, and then the second term is n choose 1, a to the 6th, b to the 1st, plus n choose 2, times a to the fifth, b to the second, and then so on and so forth. Well, if I wanted the third term, so I want this term right here, I just need to figure out what n2 is. And again, as long as you remember, it starts always with 0. So the rows start at 0, but so does the terms in each row. So this is the 0, this is 1, this is 2. So I know n choose 2 is 21, and then a to the fifth, b to the second. So there would be that one specific term. All right. And so you can kind of see here, what we have here would be the fifth row, and it's the 0, 1, 2, so it would be 5 choose 2 is 10. Okay, we'll do more practice this in class, but there is kind of the basics. Thanks for watching. Have a good day.